Dear students, yesterday we discussed about the addition of complex number, subtraction of complex number, multiplication of complex number, and division of complex number. Here, complex numbers, exercise 1A, exercise 1A. This is from Telugu Academy IPE book, Intermediate Public Examination book. So, this is the paper 2A. So, here in exercise 1A, we have the problem, first problem. If Z1 is equal to 2 comma minus 1, Z2 is equal to 6 comma 3, and find Z1 minus Z2. So, first solution, this one, first problem. What is given? Given that Z1 is equal to, this is 2 comma minus 1, you write in the form of complex number 2 minus I, and given that Z2 is equal to what? Z2 is equal to 6 comma 3, this is 6 plus 3I. So, we want to find Z1 minus Z2 is equal to 2 minus I minus of 6 plus 3I. So, it can be written as equal to real number. This is 2 minus 6 minus I plus minus common plus 3I. So, 2 minus 6 as minus 4 minus 4I. So, by complex number 4 comma minus 4, this is the minus 4 comma minus 4 Z minus Z2. If given that Z1 is equal to 2 minus I, this is 2 minus 1 and 2 minus I. Z2 is equal to 6 comma 3, 6 plus 3I. Z1 minus Z2 is equal to 2 minus I minus of 6 plus 3I. So that is equal to 2 minus 6 real part minus imaginary part. So minus of I plus 3I. This 2 minus 6 is minus 4 minus 4I. Z1 minus Z2 is equal to minus 4 comma minus 4. This is the first problem. Dear students, here we discuss about the second problem. Second problem, Z1 is equal to 3 comma 5 and Z2 is equal to 2 comma 6. Find Z1, Z2. Here given that Z1 is equal to 3 comma 5 and Z2 is equal to 2 comma 6. So, given that Z1 is equal to 3 comma 5, you write this 3 comma 5 order pair in the form of complex number, that is 3 plus 5y, and Z2 is equal to given order pair 2 comma 6. It can be written as 2 plus 6y. Okay, all of you. So, what we want to find, Z1 into Z2, this is equal to 3 plus 5y into 2 plus 6i. Okay, it can be written as 3 of 2 plus 6i into plus 5y of 2 plus 6i. So, Z1 into Z2 is equal to 3 into 2 is 6 plus 3 into 6 is 18i plus 5i into 2i 10i plus 5i into 6i 30i square. But we know that I square is equal to what? Iota square is equal to minus 1. So, Z1 into Z2 is equal to 6 plus 18 plus 10, 28i minus 30, where I square is equal to minus 1. So Z1 into Z2 is equal to 6 minus 30 minus 24 plus 28i. You write this in the order pair as minus 24 comma 28. This is the Z1 into Z2. Okay. Given that Z1 is equal to 3 comma 5 and Z2 is equal to 2 comma 6. Z1 is equal to 3 comma 5. It can be written as in complex form 3 plus 5i. Z2 is equal to 2 comma 6 is equal to 2 plus 6i. Z1 Z2 is equal to 3 plus 5i into 2 plus 6i. That is 3 of 2 plus 6i plus 5i of 2 plus 6i. So Z1 Z2 is equal to this 3 into 2 6 plus 3 into 6i 18i plus 5i into 2 10i plus 5i into 6i 30i square. We know that I square is equal to minus 1. Then 6 plus 18i plus 10i is 28i minus 30. I square is equal to minus 1. Therefore, Z1 into Z2 is equal to the 6 minus 30 is minus 24 plus 28i. It can be written in the form of order pair minus 24 comma 28. This is the second problem. Dear students, here third problem. We want to write the additive inverse of the following complex number. Additive inverse of the complex number. First problem is root 3 comma 5. For this we want to find the additive inverse of the complex numbers. Let you take z is equal to root 3 comma 5 order pair. It can be written as root 3 plus 5i. So z is equal to root 3 plus 5i and additive inverse of z is minus z. Additive inverse of z is minus z. So this one minus z is equal to minus of root 3 plus 5i is equal to minus root 3 minus 5i is equal to, you write minus root 3 comma minus 5. This is the additive inverse of root 3 comma 5. Next we go for this second problem. Second problem is given, that is minus 6 comma 5 plus this is 10 comma 4. So what we can written as, this is minus 6 written as minus 6 plus 5i plus 10 plus 4i. Okay, this one. So this is adding minus 6 plus 10 is 4, 5i plus 4i plus 9i. It can be written as 4 comma minus 1. Let z is equal to, what is 4 comma 9 is equal to 4 plus 9i. We want to write z is we want to write additive inverse of z is minus z. So minus z is equal to minus of 4 plus 9i is equal to minus 4 minus 9i. This is the additive inverse of minus 6 comma 5 plus 10 comma 4. This is the additive inverse. Next, you observe here, we want to write the additive inverse of the following complex number. First one is root 3 comma 5. Let z is equal to root 3 comma 5. This order pair can be written as root 3 plus 5y. Z is equal to root 3 plus 5y. Add to inverse of z is minus z. Minus z is equal to minus of root 3 plus 5y is equal to minus root 3 minus 5y is equal to minus root 3 comma minus 5 in the form of order pair. Next go for second problem, minus 6 comma 5 plus 10 comma 4. That means you add these two complex numbers first. That is minus 6 plus 5y plus 10 plus 4i. So minus 6 plus 10 how much? Plus 4. 5i plus 4i how much? 9i. So 4 comma 9. Let z is equal to 4 comma 9. That is equal to 4 plus 9i. Add to inverse of z is minus z. Minus z is equal to minus of 4 plus 9i. This minus 4 comma minus 9, it can be written as minus 4 comma minus 9. This is the additive inverse of minus 6 comma 5 order pair plus order pair 10 comma 4. Okay, we go for this third problem. Here third problem is given 2 comma 1 into minus 4 comma 6. Two complex number multiplication. Two complex number multiplication. First we have to multiply these two complex numbers. Then after you write additive inverse. Here given that 2 comma 1 and minus 4 comma 6. So you have to this one write in the form of complex number. So 2 plus I into minus 4 plus 6i. This is equal to what? This 2 into minus 4 plus 6i plus this I into minus 4 plus 6i is equal to 2 into minus 4 how much? Minus 8 plus 2 into 6 how much? 12i plus I into minus 4 how much? Minus 4i plus I into 6i how much? 6 into I square. But we know that I square is equal to minus 1. Iota square is equal to minus 1. So this minus 8 plus 12i minus 4i minus 6. Minus 8 minus 6 how much? Minus 14. 12i minus 8i how much? 8i. So 12i minus 4i is equal to 8i. Okay, all of you. That means it can be, this is the minus 14 plus 8i multiplication of these two complex numbers. Then we have to find additive inverse of this. Minus 8 minus 6 is minus 14. 12i minus 4i is 8i. So additive inverse of, let you take z is equal to minus 14 plus 8i. So additive inverse of z is minus z. So minus z is equal to minus of minus 14 plus 8i. So this is minus into minus plus 14 minus 8i is equal to 14 comma minus 8. This is the additive inverse of these two multiplication of complex numbers. Okay, all of you? That's all. Dear students, we go for exercise 1A. Exercise 1A. Second section. First section completed. Second section. First problem. You see all of you? First problem. What is first problem here? if z1 is equal to 6 comma 3, z2 is equal to 2 comma minus 1, find z1 by z2. So first problem solution, given that what is z1 is equal to 6 comma 3, z2 is equal to 2 comma minus 1. We have to find z1 by z2 is equal to what? So z1 is equal to 6 comma 3 is there. It can be written as 6 plus 3i. z2 is equal to 2 comma minus 1, order pair is given. It can be written as 2 minus I. So z1 by z2 is equal to what? 6 plus 3i by 2 minus I. So this one you can multiply with 2 plus I, divide with 2 plus I. So what we will have? 6 plus 3i into 2 plus I by 2 minus I into 2 plus I. So this is 6 into 2 plus I plus 3i into 2 plus I by, this is in the form of a minus b into a plus b. So this is 2 square minus I whole square. That means a minus b into a plus b is equal to a square minus b square. We know this formula, this one. So, and also I square is equal to what? Iota square is equal to minus 1. So, this z1 by z2 is equal to this 6 into 2, 12 plus 6i plus 6i, 3i into 2, 6i plus this is 3i into I, 3i square by this is 4 minus of minus 1. I square is equal to, we know that, minus 1. So this is equal to, it can be written as 12, 6i plus 6i, 12i. Okay, plus minus 3 by 4 plus 1 is equal to, this is 12 minus 3, 9, 9 plus 12i by 5 equal to 1 by 5 of 9 plus 12i. This is the z1 by z2. So it can be written as order pair form as 9 by 5 plus comma 12 by 5. This is the resultant complex number. You see all of you once again. z1 is equal to 6 comma 3. z2 is equal to 2 comma minus 1. We want to find z1 by z2. Given that z1 is equal to 6 comma 3, z2 is equal to 12 comma minus 1, z1 by z2 is equal to how much? z1 is equal to 6 comma 3 is equal to 6 plus 3i, z2 is equal to 2 comma minus 1 is equal to 2 minus I, z1 by z2 is equal to 6 plus 3i by 2 minus I. You multiply and divide with 2 plus I by 2 plus I. So numerator is 6 plus 3i into 2 plus I by 2 minus I into 2 plus I. This is 6 of 2 plus I plus 3i of 2 plus I by 2 square minus I square. You see all of you, here a minus b into a plus b is a square minus b square. Famous known formula, and also I square, iota square is equal to minus 1. We know this one, and 6 into 2 12 plus 6i plus 6i plus 3i square by 4 minus of minus 1. This I square is equal to minus 1. Minus 1 into plus minus. So 12 plus 6i plus 6i 12i minus 3 by 4 plus 1. This is 12 minus 3 is 9 plus 12i by 5. This 1 by 5 of 9 plus 12i. This complex number written as in the form of order pair 9 by 5 comma 12 by 5. This is the result. Students, you see all of you, write the multiplicative inverse of the following complex numbers. We write the multiplicative inverse of the complex number. So, you see all of you, this first problem is, what is that? 3 comma 4. Suppose z is equal to a comma b is there. This is equal to what? A plus ib. We want to find multiplicative inverse of z. So 1 by z is equal to what? 1 by a plus ib. This is equal to, we have to multiply and divide with a minus ib by a minus ib. So what we will get resultant? A minus ib by this one a square plus b square. This one 1 by a square plus b square of a minus ib. This is the multiplicative inverse of the complex number. This is the multiplicative inverse of the complex number. So here we have given z is equal to what? 3 comma 4 order pair. So this one what? 3 plus 4i. So z is equal to 3 plus 4i. Multiplicative inverse of z is what? 1 by z. That is 1 by 3 plus 4i. This one you multiply with 3 minus 4i and divide with 3 minus 4i is equal to 3 minus 4i by, what is that? 3 square minus 4i whole square equal to 3 minus 4i by this one 9. I square is equal to what? I square is equal to minus 1. Minus into minus plus 16 is equal to 1 by 25 of 3 minus 4i. This is equal to 3 by 25 comma minus 4 by 25 is the multiplicative inverse of 3 comma 4. Okay, all of you. This one we have to find multiplicative inverse like this. Okay, here we go for second problem, sin theta comma cos theta. Order pair sin theta comma cos theta. So it can be written as in the complex number sin theta plus I cos theta. So z is equal to sin theta plus I cos theta. So we have to write multiplicative inverse. Multiplicative inverse 1 by z is equal to 1 by sin theta plus I cos theta. So you have to multiply with sin theta minus I cos theta. Denominator sin theta minus I cos theta. Multiply with sin theta minus I cos theta and divide with sin theta minus I cos theta. Then you can write as sin theta minus I cos theta by, this is in the form of, you observe, a plus b, a minus b. A plus b into a minus b what? A plus b into a minus b is equal to a square minus b square. So this is sin theta whole square minus I into cos theta whole square is equal to, what is that? Sin theta minus I cos theta by, in denominator, sin square theta, this one I square minus 1 minus into minus plus cos square theta, where I square iota square is equal to minus 1 and this one a plus b into a minus b is equal to a square minus b square. And also we know that sin square theta plus cos square theta, this sin square theta plus cos square theta is equal to 1. This is the trigonometric first identity. So you can write as this one sin theta minus I cos theta. Therefore 1 by z is equal to sin theta minus I cos theta is equal to what? Sin theta minus cos theta minus cos theta. This is the what is that? Multiplicative inverse of z. Okay, all of you. Dear students, this third problem 7 comma 24, you write, you do this problem like this, and you do this problem this like this. So this as practice. You practice this. You do your own. You do this one your own. So these are the practice problems you can do. That's all.